Hi, I'm Bob Dopkin. I'm the Vice President and CTO at Linear Technology, and I want to talk about one of our LDO Plus regulators. Our Plus indicates that these do more than just regulate. They've got monitor and control functions as well as regulation. The LT3081, designed to be a wide, safe area industrial regulator. It'll operate with output voltages from 0 to 37 volts. It'll take reverse voltage, and it will continue to supply power with large input-output differentials because it's got a large safe area. In addition to regulating, it has a current monitor output, so you can look at the current through the regulator, and an external resistor will set the current limit down below the max output current. It's got a temperature output, so you can monitor the temperature of the system. That makes it really easy to debug a system when you're first putting it together, as well as make sure it's operating right. Unlike any other regulator, it needs no output capacitor. It's stable with no output or input capacitor, which means it can be used with long lines, it can be used in areas where intrinsic safety is important, or it can be used as a current source. Finally, it's adjustable down to 0 volts, which means as the logic voltages go lower and lower, this will never be obsoleted. This is the basic circuit of the LT3081. We have two current sources for monitoring. One provides an output current proportional to temperature, and we get 1 microamp per degree C. The other current source is proportional to our output current, and we get I out over 5,000 through the 1K resistor to ground. Now, this is a floating regulator. What happens if we short the output? We can still get useful signals out of our current monitors. These have a compliance of 400 millivolts above the output voltage. So if the output is tied to ground, these will still read correctly as long as the resistors are small enough that our voltage across them is under 400 millivolts. As I mentioned, we can make a current source, and not having an output capacitor means that the output impedance of the current source to AC changes is still very high. We take our internal current reference and we feed it through an external resistor here. Typically, we put about 200 millivolts across this resistor. So we have our 50 microamps flowing through a resistor to set up an external reference. Then we put our current set resistor from the output back to the common point. So if we were to have 200 millivolts across here and we put 1 ohm here, we'd have a 200 milliamp current source with good compliance and wide operating range and good AC output impedance. One of the other nice things you can do with a current monitor output is you can compensate for line drops. Let's say your load is somewhat distant from the regulator, and you still need to keep the load within a few percent of regulation while you have a 10 or 15 or 20% drop in the wires running to your load. We can have this device do cable drop compensation. What we do is we feed the current monitor through a resistor that boosts up the output voltage as the current goes up. So as the load increases, the output voltage at the regulator goes up, but the voltage at the load stays constant. So we take our current monitor, feed it through a portion of the resistor on the set pin, and that gives us our compensation for line drops to the output device. The data sheet has all the formulas for the resistors as needed. One of the nice things we can do with these regulators is we can easily parallel them. I don't know how many times I've had customers want to parallel 2 regulators to get more output current. But normally, this ends up with one regulator hogging all the current and the other one running lightly until the first one goes into current limit. It's not a good situation for reliability and for good current sharing. With these new architectures, where they're hooked up as a follower, it's easy to make them current share just using a very small ballast resistor. Here is the offset voltage distribution of the LT3081. The offset voltage from the set pin to the output has a distribution underneath plus or minus 1 millivolt, the same as some good op amps, which means that only a very small drop is needed to get them to current share. In this case, we tie the set pins together. That makes the outputs the same. Resistor to ground to set the output. Then we only use 10 milliohms to make them share current. At 1 amp output per regulator, 2 amps total, there's 10 millivolts across the 10 milliohms. And that gives, worst case, 20% current sharing. If you want better current sharing, you can take that to 20 or 30 milliohms and still have very good regulation. These resistors are small enough that they can be achieved with a small piece of PC board or a small piece of wire. So it becomes very easy to parallel two devices. Doesn't take any extra parts really, just a piece of PC board, and you can get good current sharing. Here's the actual circuit for paralleling regulators. It's very, very simple. We tie the monitor pins together for the current monitor because we want to know our total current. The set pins are tied together so that the outputs are at the same point. We set our current limits. We tie those together so that we can have an external current limit. We look at the temperatures independently because in a system, depending on the airflow and the way that they're heat sunk, you will have different temperature. And we tie the outputs together to a ballast resistor. These regulators provide a lot of information as well as regulation, make system design easier, and they're very rugged in industrial applications. Thank you.